Hello, welcome to one of my normal live solve videos. Today I'm also posting a special walkthrough video, but I wanted to do a normal puzzle as well. And today I chose Cage Fright by Dr. Logic, and I just thought that the rule set was kind of cool. We'll see how it goes. This has both anti-knight and anti-king rules, so two cells that are knights move apart, which means two digits away, two cells away in one direction and one cell in a different direction. They can't be the same digit. And also adjacent digits, whether diagonal, well, two adjacent digits orthogonally can never be the same as Sudoku grid, but diagonally adjacent digits also cannot be by this anti-king rule. So this combination is actually quite restrictive because, say I have this cell, right? Then if I think about, especially near the edges of boundaries, so if I think about where this cell can go in, say, the middle cage, well, it can't go by normal Sudoku rules there. By the anti-king rule, it can't go there. By the anti-knight rule, it can't go into those spots, right? So very quickly, and it's even more so, right, for this one, all of these get taken care of. It's just one of the bottom corners. So that pair is very, very restrictive. My guess is we're going to end up doing some either color coding or lettering rather than numbering throughout this process. And I really like doing that, which is why I chose this puzzle. I've got Nabner Line. So these came out, I think, this year sometime. And they had a little run of being very popular. I really like them. The basic idea of a Nabner. So Nabner is Renban backwards, which means basically it's like as far away from a Renban as you could possibly get. So rather than a string of consecutive digits, it's none of the digits are consecutive, right? And not just adjacent digits, right? None of the digits can be consecutive. So, um, you know, for this 5-length line, what that means is this digit is not consecutive or the same as any of the other four, right? This is not consecutive or the same as any of the four, right? So all 5 of these are completely different. And so you end up getting this kind of spaced out effect. And in fact, I can see right away, if you have a 5-digit Nabner line, the only way to satisfy that is to have the odd digits 1 to 9. So 1, 3, 5, 7, 9. I've got white Kropke dots, 2 of them here. So these 2 digits have to be consecutive. These 2 digits have to be consecutive. And I have these killer cages, which are normal killer cages, meaning that they just cannot repeat within a cage, which is only going to matter for these. And further, that they sum to the number. But the number here is obfuscated by this algebra equation involving x that I don't know, but x is going to be somewhere between 1 and 9. So those are the rules. Try yourself first, and I'm just going to do it. So where do we start? So as I said before, these have to be 1, 3, 5, 7, and 9. Right? The only way to get 5 digits where none of them are consecutive is to do it that way. So suppose that weren't true, right? So for example, suppose I had a 2 in here somewhere. Well, 2 eliminates 1, 2, and 3 from being here. So the rest of the digits have to be 4 or higher. And then, if I try to kind of crunch as close together to this 2 as I can, let's say this were a 4, and this were a 6, and this were an 8. Again, that's kind of the minimum I can make these to squeeze them together. Then what do I put here? There's nothing left to do it. So I can't have even digits here. These are just 1 each of the odd digits. And I'm seeing now that I think on this Nabner line, every one of these sees by either the king or knight's move every other one. But I'm just going to, so this cell can't see these by knight's move and this by normal Sudoku. So this is not on the line, so this is an even digit. This by anti-king, anti-knight, and normal. That doesn't. This, right, anti-king, normal Sudoku, right? So these 4 digits see all of these 5, and so they can't be the odd digits, so they have to be even, and they all have to be different because they're on a Nabner line. So I think what I'm going to have to do is I'm probably going to have to color code odds and evens is my guess. So I'm going to start with reds as odd and blue as even, I guess. I don't have like a standard odds and evens color coding. I probably should. So we'll do pink or purple as odd and blue as even. And now I'm just looking at cells close to these, like these cells on the border, and seeing, like, for example, this cell. Could this cell be odd? Could it be even, right? So if it's odd, it's going to have to be this cell because it sees all of these, right? If it's even, it sees these two, so it'd have to be one of those two. But either one of those seems fine. The other thing I'm seeing here is this roping that's being caused by this cage. I think the reason this cage is here is to show you, well, where do these three cells go in box 2? Well, they can't go here by normal Sudoku. They can't go here by the cage constraint. So these three cells have to be here. Oh, and because of, okay, I think that's actually maybe what I'm supposed to do first. So let's say I label these cells A, B, C. Where does A go in box 2? Right? A can't go here, can't go in the cage, can't go here by king's move, can't go here by knight's move, and so A has to go here. And then B, we can do the same thing. It's got to go in the bottom row because of normal Sudoku and the cage rules. You can't go here by knights, so it goes here, and then this has to be C. And so I mentioned roping before. This is actually going to end up kind of passing along to cage 3. So if I have ABC in the middle row of box 3 and the bottom row of box 2, then they have to go in the top row, and that's going to end up transferring. That kind of pattern is going to work for every single value here. So let's call this DEF. Where does D go in box 2? Can go here by normal Sudoku. No knight's move, no king's move, no knight's move. These are taken, so this has to be D, E, right? Oops, F. And then where does DEF go in box 1? Actually, I can actually place them. So D, right, can't go any of these. These are taken by ABC, anti-king, anti-knight. So that's D, that's E, that's F. If I call this, let's see, do I want to call this GH and I, or do I want to call this GH and I? I'm not sure. So I'm gonna leave it for a second. So if I'm going to call this GH and I. Why this? If I call this GH and I, so why was I able to place DEF all the way across? It's because I was only moving one row at a time as I passed along. ABC, when I go from here to here, I have kind of two rows separating them, one row in between them. And so I can only place, say the A is not here, and the rest could be any which direction, right? Whereas DEF in the middle, that showed me where these were here. So if I put GHI here, I'm not going to know where it goes here, and it's going to get even more confused here. Whereas if I put GHI here, I know that G is not here by anti-king, here by anti-knight, so it must be here. H is not here by anti-knight. Must be I then. And then here, this can't be I, so it's G or H. One of these is I with G or H. I'll do the same thing here. One of these is A. And then I can do the same roping here. Is that useful? Because I don't have all three, so I'm wondering whether that's going to... Well, I have D and G, so... Right, so the way the roping... I'll color code it this time. Where do the, let's say, greens go in box 7? Well, they're not here by Sudoku. They're not here by the cage rules. So the greens are here. The greens are here. So where does E go? Not here by king, not here by knight. That's E. Where does H go? Not here by knight. That's H. And then this is one of A, B, and C. I don't know which. And then I can do the same thing, right? So if I call these, let's call these orange, then where do orange go in box 7? Not here, so they must go here, and therefore they go here. And then these must all be the same. So again, this is this idea of roping that you end up with kind of these 3 digits that are, at least in this case vertically and in this case horizontally, kind of sticking with each other from box to box. And because of the anti-knight and anti-king move, at least for the most part, they're in the same order. Here, they don't necessarily have to be. So I'm trying to be extra careful. Like this could just be CBA again, but I don't think it has to be. So I'm going to leave it like that for now. And then I can place F here. I, and then this is either B or C. This I can't do as well. Yeah, and then I like A. This orange cell could be anywhere. So, but I can place F and I here as well. And then I can't place, I can put E in one of these and H in one of these, right? And these are, this actually isn't D because this sees, the two possibilities for D are those two cells, that should be, are these two cells, this sees this by king, this sees, and this sees this by knight, so this can't be D. But any of these could be G, and then any of them could again be A, B, or C. So I think that's the best I can do. I'm going to get rid of this color coding because I think I'm going to end up getting confused with my odd even coloring. So maybe I should look at these x's. So what can I say? What is the most x could be? So the most, I think the most, so this is, the highest x could be here is 10, that'd be 23. Because if it were 11, that'd be 25, that's too big. Here it's also 10, that'd be 17. That's the highest a 2-cell cage can be. Oh, but actually in the rules, x is between 1 and 9. So that's actually no higher than 9, which I guess is not so helpful. It's the lowest it could be. These are pluses. This is minus. So this is x minus 3, which you can't really see because my marking's here, but this is x minus 3. So, so the lowest this whole cage could be is 3. So lowest x can be is 6. So x is either 6, 7, 8, or 9. And I'm wondering if at some point I'll be able to say whether it's even or odd, right? Because, you know, if I could fill in the odd or evenness of these, any of these really, I can figure out whether x is even or odd. Actually, I know this is odd. No, sorry, I know this is even. Well, I know this is even. Well, it doesn't matter whether x is even or odd. 2x is going to be even. Plus 3 is an odd number. Even plus odd is odd. So this whole cage has to be odd. These two, even plus odd, will be odd. So the thing I have to add to it will be even. And so this cell, unmarked, is yellow. Can't be this. Can't be this by king's move, this by knight's move. So the yellow cell is here. So that's going to be either D or G. I don't know if I know which one it is. I'm sure I don't know which one it is. Whether someone else could figure out which one it is, that's a different question. I don't want to do color coding and lettering. Maybe I should have called these A, B, C, D, E, F, G, H, I or something. Well, I'm going to stick with this for now. Yeah, I'm going to stick with this for now. Oof. I'm going to stick with this for now. Oh, okay, so one of these is yellow. And then if yellow is D, it's here. If yellow is G, it's here. One of these is yellow. So why can't these be yellow? Because this one, anti-king, anti-knight. So yellow is either GH is G, which could be any of these, but yellow specifically will be here or here. With this, do I know if this is odd or even? If it's even, it's one of these two. If it's odd, it's this one. Okay, can B be odd? Yeah, easily. It could be any of these. It's hard to be even. It has to be this one. A could be even. Well, hold on. This is also A. Well, it doesn't matter. Okay, if suppose A is even, then A is one of these two. If this is A is not here, A is not here. These two by anti-knight mean A is not here. So if A were even, it'd be one of these. That's not helpful at all. Actually, A is starting to interact here, so one of these is A. I don't know which. Right, so if this is A, then this is A, then, wait, hold on. If this is A, no, then this is A, then this is A. Right, I know this is this, whatever it is, but I just don't know which they are. Now I'm wondering, maybe I should have labeled these as letters. So where does this cell go in here? It's either E, F, or C, but it's not C. It's either E or F. It's not F, so it's E. Okay, so that's E. E. So this is E. So what? So E is here and here, all these. And so where does it go? In box 5. Can't be those, or these, or these, or this by King's move. So that's E. This can't be E by the Nabner line, because every digit on the Nabner line has to be different. These can't be E by normal Sudoku. So E is one of these. Now I've got an X-wing on E's, so one of these are E's, but not this one or this one. So that's E, interestingly. Yeah, I probably should have just labeled these to start with, but, well, I guess I kind of needed both, right? Because to get this E, I needed to know that these two were the same, which I only got by labeling them, and that, right, and that these two were the same. So maybe that is the right way. Maybe I did it the right way. What about here? So C's are odd. That doesn't really help me. I want to know if this is, but I don't know if I can do that. What about this cell? I already did that. It's D or G. Can I do something with this cell? It is, what's called, I'm going to mark this purple just so I remember that I found it. So this is not E. So it's none of those or E. So it is something like this. It's not C. Yeah, it could be this, right? It has to be H or I, but that's fine. Let's see. B is either here or any of these. If B is, well, either of these, right? So if B is one of these, it has to go in one of those slots. And then, yeah, I don't know if that helps me. Well, hold on. Actually, B is, right, as I said in the beginning, B is one of these. So B is one of these, and it's one of, so B is one of these. So B is one of these. Oops. But not this one by Knight's move. So B is one of these. Doesn't help me. Right, because I have all three here. So I don't get the X-wing. What about A? Can A be odd? Yes, it can be there. And if that were true, wait, no, because then where would A go? A cannot be, okay, A is even actually. So that's big. Why is A even? If A were odd, then on this, where does it go on this, on the odd Nabner line, right? All of these are seen by an A, which they're all seen by this A. So that has to be A. But if these two are A, where does A go in box 5? It can go here by Sudoku, here by anti-king, or here by anti-knight. So that breaks. So A is not odd, A is even. So A is one of these, which means by anti-knight's move it's not here. So A is here, and therefore here. Right, A is not here by knight's move. And then what? A is not any of these. A is one of these two. And it's one of these two. Yeah, I think I've run out here. So A is one of these, but not this one. So one of those is A. What about D? I just really want to know if X is even or odd. And so I keep going to these cells to try to think about whether the sum is even or odd, right? So I know that these are different polarities, right? One's even, one's odd, because these pairs of cells have to have the same polarity, because this is x and this is x plus 2. So if x is even, x plus 2 is even. If x is odd, x plus 2 is odd. So D, where does D go in box 5? Can't go here by this D. It can't go here by knight's move. It can't go any of these by knight's move with these two. So D is one of these. So D is even. Okay. D is even. So that tells me that x plus 2 is even, which means that x is even, which means this is odd. So this, I'm going to flash orange, is this one, because this sees the other odds. So this is either G or H. I'm going to get rid of, I'm guessing I'm not going to be able to, like, I'm probably going to have to do the whole grid and like figure out X to, so I'm just going to ignore all the digits actually and just use letters from here on out until I see a reason to substitute some letters in. So I don't know whether this is G or H, but I know this is orange and this is orange. Where does orange go in box 5? It can't go here by normal Sudoku, here by king's move, here by knight's move, here by knight's move, here by knight's move. It's not E. So orange is here. But it's not G. So orange is actually H. And I don't need to say orange anymore because I know what it is, and those are all odd. So that's not H. So now I've got an EH pair here. So what does that make this? That makes this cell, whatever that is, A, B, or C. Okay. About this. This is odd. So I'm going to have an odd. I can't have 3 odds because then that would be too many odds here. So I need 1 odd and 2 evens. This is also 1 odd and 2 evens. That helped me. So this is not even because this sees all the evens. So this must be odd. 1 odd. Can't have 3 odds. So 1 odd and 2 evens here, we said. This is one of these two, but I don't know which. This could be any of these. Right here. Here again, I have 1 odd and 2 evens. This could be even. This could be even. This could definitely be even. So this actually sees all the odds, right? So this sees these 3 cells because, so I don't have letters here. So, but these 5 cells, right, are all the odds by the Nabner line. I can change this H to here, and I still have the set of 5 odds. And these all see this cell, right? It sees C by knight's move, H by king's move, and the other 3 by being in the same box. So this is not odd, that's even. And it's one of these two, I don't know which. So I have 1 more even and 1 more odd here. This could be yellow. I was going to say it had to be yellow, but this could be yellow instead if the D is yellow. Okay, so A is even. Oh, B is even. So these are all odd. Wait, no, I don't know B is even. Why did I think that? These are all odd, so E is odd. So these are even because I've now got, if one of these is odd, that's 4, 5 odds. These are both even then, so F is even. Okay, so my evens are A, D, F, and something else. A, D, F, and something else. I don't know what something else is yet. Okay, what about B? Can B be even? If B is even, then it's this one, and it's this one, and it's here. I think then I run out of steam. It's one of these two. Yeah. So B could be even. Can B be odd? If B is odd, it's here, and therefore here. Again, I run out of steam in exactly the same place. This is odd, but I don't know what, because this whole thing is even, and this was odd. This is an odd and an even. There's only 1 more odd in this row. D is even. So I've got one odd and two evens here. The odd has to be here, or this has to be an odd even pair. Right? So in this column, I've got 4 odds and 2 evens. This is 1 odd and 1 even because consecutive digits will have 1 of each. That's 5 and 3. That makes this even. This sum is odd, so that's odd. This whole thing is odd, so this is an odd even pair. I don't know if that helps me somewhere. I've got 3 evens here, so I have an even and 2 odds here. I've got an even and 2 odds here. This is an even and odd. So this is an odd and 3 even. No, sorry, an even and 3 odds. Let's see. One of these is D. I already knew that. So D is one of these. D is one of these. Yeah, not helpful. Okay. Where does this go in box 6? One of these, but it could just be here. It could be here, so that doesn't tell me much. Right, because this can't be F. So if this were here, it'd have to be here, but that's fine. That could be A, D, or G. Or B or C, I guess. Not C, because C's odd. Or B, actually. But that's all predicated on this being here, which doesn't have to be. This could be here instead. That's too many steps ahead. All right, there's got to be something simpler. Where does this go in box 5? Not here, not king's move, not knight's move. It's not H because of this. So this actually is this, but I don't know that it's B. I wanted to say that means it's B, but I don't know that for sure. I'm going to get orange, though. And then orange is one of these. It's complicated. Double. But it is B or I. No, it's not I. It is B. Right? So what is this cell? What are these cells? And I saw that in box 2. Right? It's not C. It's not E, actually, from here. It's not A, D, or G by this one. It's not F because that F is even. It's not H because of this H. And it's not I because of this I. So the only thing is this actually is B, which is odd. I don't need the orange anymore. I already knew B was one of these. B is now odd. And these are not B. Okay, so we're getting closer. C, B, E, and H are 4 of my odds. I've got one more. And then F, D, and A are 3 of my evens. And between I and G, I've got 1 even and 1 odd. This is 2 odds and an even. This is 1 odd and 1 even, because again, this is x minus 3. X is even, minus an odd number will be odd. This is one of each. Let's see, this is one of each. So I've got 3 odds and 3 evens. 4 odds and 4 evens, that must be odd. B or C are both odd, so it doesn't help me much. One of these is C, because C has to be odd. It's none of these, because those are other letters. That's not C by king's move, so that's my C. So this is either G or I, depending on which one is odd and which one's even. A is one of these. F is here. D is any of these. And then the other G or I is just whatever's left. I'll put TGI in here, but that's why is it's not I because of this. So I is not even. G is even. I is odd. G is even. Let's see. So G is the odd, or I is the odd one here. And then this is also I. Where does I go in? That could be any of these. In box 9. That's now A. Means that's not A, so that's A. That's A. We said A is even. And then BC is odd, A is even, BC is odd, I is odd. This is one of each. So one of them is B or C. The odd one is B or C, and then the even one is D and G. So the two marked ones here are even, and whatever's left, BC, is odd. And BC, that has to go here, so that's not G. Because of this BC pair, these two see both of these by either knights or kings move. This sees this by knights move, so that's C, that's B, that's B, that's C, that's B. This is G, D, C. That's not A, so this is my A, this is my A. So this is my A. So this is my A. This is just a DG pair. Let's see, H, I, E, B. This is C, is my only odd missing. What's the odd missing here is H. So one of these is H, but I don't know which. I do know which apparently. Knights move here. So that's odd. That's even. These are D, G, F in some order. This one, whatever it is, goes here, which is D or G. It's not G because it sees both possibilities for G here. So this is D with this, that's G. So that's G, because the yellows are now G. Get rid of the yellow markings. That's G and D by this D. This is G and F. So by this G makes this FG, makes this CGD. I think, yeah, at this point, I should just be able to fill everything in. What's missing here is G, because this C is F and D. This is E and B. Oops. This is, let's see, A, B, C. This must be D. What's missing? A, B, needs C, F, and I. C makes that C, I makes that I, and F. And then, let's see, this is, we need B and C, D, E, F. We need B and I. This I means B and I. That gives me E and B, gives me E and H. Let's see, we need a D and a G, no, D and H. This H means that's D and H. Here we need C, F, G. G makes this G. We need C and F, F, C. So we've got everything labeled now. I think I want to get rid of the colors because I didn't really finish the colors. And I don't think it's going to help. I think we just need to, like we have, what do we do? So we said that X is even, right? Because these are odds. So those are odds. So two odds makes X even. Maybe I should have left the color coding, but it's too late now. This is odd. So what did we say before? The X was somewhere between 6 and 9. X is even, so it's either 6 or 8. So this low cage is either 3 or 5. If it's 3, this is 1, 2, and I would know which way because A is even and C is odd. So it would be 2, 1. But if it's 5, it could be 1, 2. A could be 1 or 3, and C could be 2 or 4. So C is 2 or 4. This is 9, and it has 2 evens, right? So these are my evens, A, D. 2 evens and an odd. So that could be 1, 2, 6. It can't be 1, 3, 5. There's 1, 2, 6 or 2, 3, 4. So one of these is a 2. Could D be 2? So if D is 2, A is 4, then C would be 1. So actually this would break. Actually C is just, so yeah, easier. A and C are here. A and C are here. A and C is X minus 3. If I add D, that becomes X plus 3. So D must be 6. D must be 6. And now that means A and C, let's see, X is 6 or 8. Yeah, it doesn't, I mean, of course it doesn't help me because I solved it using that. So D is 6. Did that get us here? So X is 6 or 8, which means X plus 2 is 8 or 10, which makes A 2 or 4. I think we already knew that. A is 2 or 4, C is 1 or 3. X is 6 or 8. X can't be 6, I think. So hold on. If X is, so the reason I'm looking at this X, this sum is either 6 or 8, but A and C, which has to be pretty low, are taken. And in fact, if X is 6, A and C are 1 and 2. If X is 6, A and C are 1 and 2. And then what do I put here? So X would have to be 6. This has to sum to 6. Without 1 or 2, you can't do it. So X is not 6. X is 8. Which means A is 8 plus 2 is 10. A is 4. C is 1. So if X is 8, 2X plus 3 is 19. Minus 4 is 15. There are 2 ways that can go. So H could be 7 or 9. G could be 6 or 8. Oh, but 6 is taken. So G is 8. H is 7. 7 is taken here. Can't be 2, 6. Well, they're both odd in the 6s. So this is 3, 5. E and B are 3 and 5 in some order. Do I know which way? E is not in any. Oh, but E is attached to the 6. So E is 5 and B is 3. What do I have left? I and F. F is adjacent to 1, so that's 2. I has to be whatever's left, which is 9. And I'm going to check to see that that's right. And if it is, I will post this video. All right. So thanks for watching. This was Cage Fright by Dr. Logic. I love coloring puzzles. I love anti-knight puzzles. The addition of the anti-king, I think, I mean, you had to do it to get that. Yeah, this is just a fabulous puzzle. Thank you for setting it. And thank you for watching. Bye-bye.